Hello, welcome again to Block 2, Use of Algebraic Notation, Lesson 7. I will share my screen. Okay, so in your previous lesson, you learned about substituting into single operation expressions. Okay, in today's lesson, you're going to learn about using numbers to work with two-step function machines. Okay, but before we start, I would like you to have a go at these retrieval practice questions, which will get you thinking about your previous learning. Okay, you can pause the video and do these questions in 3 minutes. Now, I'm going to presume you've done that, so I'm going to reveal the answers and I'll discuss the answers. Okay, so here are the answers. Here, for question 1, you're asked to simply add 19. So the function machine is adding 19 to whatever input. So in this case, our input is 12, and so our output will be 31. This one, the function machine simply multiplies by 5. Okay, it simply makes 5 times larger whatever is put in. So here we have 18. And then for this one, we have the output, but we do not know what was put in. We don't know the input. So remember what we did to find out the input, we have to do the inverse. Okay. And then remember the inverse of square root is to square. So going from here, okay, to here, that way, we have to square because that's the inverse of square root. So we square 9. So 9 squared is going to be like that. Okay, and that's 81. And then here you're asked to complete the function machines in 3 different ways. So we know 6 times 6 will be 36. We can also add 30 to 6 to get 36. And you can also square, or 6 to the power 2 to get 36. So I do hope those are the answers you got. If not, then you can just learn from your mistakes. Okay, you're always learning. Okay, let's move on. Let's do some new learning. So if I give you this function machine, if I say, let's put in 8, you would say, I know this. We had this in our previous lesson. The answer is 80. But remember, the title of our lesson is two-step function machines. Okay, we're going to be doing 2 operations. Okay, or you can even have the same operation, but different function machines. But in this case, we're doing 2-step function machines. Okay, what if we put the input into another function machine, which is to add 7? In this case, our answer will be 87. However, the way you would see a 2-step function machine is like this. Okay, so you have an input, you have one function machine, you have an arrow pointing to another function machine. Now, what if we have this problem? Have a think. What would the answer be? You would say, okay, that's 13 subtract 9. And then whatever I get as the output of 13 subtract 9 or 13 minus 9, I'm going to multiply that by 8. Now, good practice, what I would suggest is whenever you're dealing with questions like this, it's good to write the first output somewhere Because if you're trying to do all these in your head mentally, you may forget. So just write it on the side somewhere, and then you know what the input to the second function machine will be. In this case, your answer will become 32. What about this one? Here, we need to add 3 and then multiply by 6. And in the next step, we're multiplying by 6 and adding 3. I want you to think, do you think you would get the same or different result? Do you think the order of operation will affect the result, or will it be the same? Okay, let's see. Of course, the results will be different. You can see the results will be different. So you need to know that the order of operations can affect the output of a function machine. Okay, it's really important for you to take note of that. Okay, I would like you to pause the video and have a go at questions 1, 2, 3. Here are questions 1 and 2. You can pause the video for 4 minutes and work through the questions, really thinking about what you've learned. You may be able to do it quicker than 4 minutes. But when you finish, check your answer. So I assume you've already done that. So here are the answers. So here, these are really simple function machines, two-step function machine. Here you need to multiply by 2 before you add 1. Here you need to multiply by 4 before you add 8. Okay, here you need to multiply by 3 before you subtract 1. And here you need to multiply by 5 before you subtract 3. But this question, Teddy says that these two function machines are the same. Is it true? Is it correct or not? Of course, you can test it by using the same input, isn't it? So if we put 1, you see that your output is 10, and then here your output is 28. So remember that example we had, the order of operations will affect the output of your function machine. Okay, so it's incorrect, yeah? Okay, so here is question 3. You can pause the video and try to do question 3 in 3 minutes. You may be able to do it quicker than that. So assuming you've already done that, so here are the answers. Okay, so here are the answers for question 3. Okay, so you were asked to complete the two-step function machines. Okay, you simply do the operations just as we learned, and then you get your results. Okay. But what if we have something like this? Okay, so we've learned that we've learned that the order of operations matter when you do function machines. Don't forget that. But what if we don't know the input? Okay, so you remember from our very first one of our lessons where we worked with single function machines, when we didn't know the input. I'm sure you remember now. Drum roll, drum roll. Okay, we do the inverse operation. So we're going to do the same here, but we'll do the inverse operation twice. Okay, so in this case, we'll do the inverse operation first. The inverse of subtracting 5 is to add 5. So we'll do 19 add 5. And then you can write your result somewhere here in the middle. to make sure you don't forget what your result is. And then the inverse of dividing by 3 is to multiply by 3. Then your answer will be 72. Okay? All right. So what you've learned so far is you can do inverse operation to find the input of two-step function machines, and then you just need to know that the inverse of multiplying is to divide, the inverse of dividing is to multiply, the inverse of subtracting is to add, the inverse of adding is to subtract, the inverse of square root is to square, or the inverse of squaring is square root. Okay? All right. I would like you to pause the video and answer questions 4 and 5. This should take you about 3 or 4 minutes. You can work at your own pace. Now, assuming you have paused the video and worked through the questions, you've really thought about what you were doing, here are the answers. So here is the answer to question 4. Okay, question 4, Doro is finding the input for this two-step function machine. When finding the inputs, you need to use the inverse operation. Of course, that's right. And then here is our working out. So let's check Doro's answer. So it says check Doro's answer by imputing 1 back in to the two-step function machine. We need to check whether Doro is right. So Doro did not work backwards. Okay, she did not work backwards. Okay, she should have done 36 subtract 8, because the inverse of adding 8 is to subtract 8. So Doro should have done this. Okay, remember inverse operation. So she needs to find out this should be to subtract 8. She will get the result, and then next she needs to divide by 4. The inverse of multiplying is to divide. Okay, so Doro is wrong. Okay, let's move on. And here are the answers to question 5. Okay, so to find the input for this one, for A, we do 27 subtract 6 and then divide by 3. Okay, here we do 72 divide by 8 and then subtract 10. Here you do 25 add 3, because you're doing the inverse to find what the input was, and then you divide by 4. Okay, all right, so on and so forth. Okay, if you have a question that is given to you in words, something you need to know. So here is the question. It says a number is tripled and 4 is added. The result is 55. Okay, what do we need to do? It's important you note that when you read questions, follow the order in which the operations are given to you. So if we were to draw a function machine and to write this thing out, what do you think it will look like? Of course, you know it's going to look like this. Okay, to triple means to multiply by 3, and then you add 4. But if we want to find the input, don't forget, we do the inverse operation. Okay, we subtract by 4 and then we divide by 3. Okay, really important that when you work through word problems, you think about the order in which the question is being asked, and then you write out following the order in which the question is being asked. So here you see a number is tripled and 4 is added. Okay, see the order in which is given to you. So you write from left to right. Okay, of course, your answer will be 17. Okay, I would like you to have a go at the rest of the questions. You can pause the video for 2 minutes to do question 6. Now, I will assume you have paused the video, you've really thought about this through, you've worked really hard. So here is question 6. The answer here, Amir is thinking of a number. If I double my number and add on 2, the answer is 80. We're asked to draw this as a two-step function machine. You remember what we said? You follow the order in which the question is given to you. So Amir doubles, so you times by 2. Next, he adds 2, and then the answer is 80. Okay, and this is how our function machine would look like. And then it says use inverse operation to work out Amir's number. So if we use inverse operations, we're going to do 80 minus 2. So 80 minus 2. So minus 2 or subtract 2, which will be 78. And then divide by 2. 78 divided by 2 will give you 39. Okay, which is this here. All right. Okay. All right. So here is the answer to question 5C. So Eva is thinking of a number. If I halve my number and subtract 7, the result is 15.9. And told to draw this as a two-step function machine. To halve means to divide by 2. But you can simply write times half here. Yeah, it's still the same. Remember one lesson we did? To divide by 2 is the same thing as multiplying by half. Yeah, and then subtract 7, and then the answer is there. And then it says use inverse operations to work out the number Eva is thinking of. Okay, remember our inverse operation, you do 15.9 plus 7, you add 7, and then here dividing by 2, the inverse is to multiply by 2. When you do that, you'll get this result. Okay, now you can use this as a little exercise with your friends, with mom and dad. You can think of a number problem, think of a number problem with your friends and family. Okay, that's the end of our lesson. So far we have learned that you can work with two-step function machines by using the adequate substitution. So you put the numbers in two operations and you get the numbers out. And then to get the inputs, if you were not given the inputs, we'll do exactly what we did when we did the single function machine. You do the inverse operation. Okay, you start from the right, doing your inverse operation of each of the operations until you get to the left. Now, when you're given word problems, it's really important that you read the question and do the operations, writing your function machines from left to right, following the order in which the question is given to you. Okay, until next time, take care and bye-bye.